Okay, for part 2 of equilibrium and yield, we are going to look at Le Chatelier's principle. We're going to explore a little French. No, Le Chatelier was a Frenchman, but that's the only French we will be exploring. So, let's get into it. So, Le Chatelier's principle, what does it tell us? If a change is made to a system at equilibrium so that it is no longer at equilibrium, a net reaction will occur, if possible, in the direction that counteracts the change. All sort of very confusing. But basically what that says is if you increase the concentration of a reaction at equilibrium, the reaction will try to decrease the concentration. If you increase the pressure, the reaction will try to decrease the pressure. If you increase the temperature to a reaction that's at equilibrium, the reaction will try to change to decrease the temperature. So basically, Le Chatelier always wants to fight you. If you change something, it wants to put it back like it was. So let's say we have a reaction here where we have some reactant going to some product, and we are going to increase the concentration of reactants. What does that look like? We are going to throw in, and this is what you might do if you're running a chemical process, we're going to throw some more reactants in. So up here, we're just going to increase the concentration of reactants. So Le Chatelier's principle says that the system will try to change to counteract that change. So the reaction will try to decrease the concentration of reactants. So we throw some more in, the reaction says, no, I don't like that, and it tries to decrease it. Obviously, if we are here losing more reactant, the reactant is decreasing. It's decreasing to make more product here, so the product will also increase. So what that basically says here, an increase in concentration of reactants, dunk, equilibrium shifts to the right in favour of the formation of products, i.e. we get more products. So the products, if you like, come down to this line, will start to increase. As they increase, the amount of reactants will decrease. That's the counteracting the change of an increase. Therefore, we lower the concentration of reactants. Okay, now let's look at what would happen if we have an increase in the concentration of products. So, products here are in green, just put a little P there. So, suddenly we are going to increase the amount of product. Now, the reaction is going to say, I don't like that you've increased the amount of product, so I'm going to try and decrease the amount of product. So this will drop down like such. So it will try to decrease the amount of products. Obviously, if you decrease the amount of products, you're favouring the reverse reaction. So we've got the products going back to, so it's a bit messy, we've got products being forced back to reactants. So we're going to get more reactants formed. So we would see a change like that. Now, I thought about doing this one in the lab, but it's just a little bit dangerous because it needs concentrated hydrochloric acid and it needs quite a bit of it. But there's a really good link to a video here to look at a reaction between cobalt chloride and hydrochloric acid and watching the effect on a colour change reaction, that what happens as you change the amount of reactant and product. So I'd recommend you have a look at that video just to see an example of one of those. Now, let's look at changes in pressure. And pressure is a little bit like concentration as well. So, let's say we have a reaction here where we have two A molecules combining to form one B molecule. So we've got A, being used up at twice the rate B is forming, because we need 2 for each of these. And we're going to increase the pressure. So when we increase the pressure, it's effectively like increasing the concentration, because if you increase the pressure, that gas is squeezed into less volume. Basically, moles per volume, moles per litre is what concentration is. So if we do that, we get the increase, that sudden increase in both of them as the pressure increases. Now, it's a bit neat what happens here. What this reaction will do is it will try to lower the pressure, i.e. produce less gas molecules. So if you can see, if this reaction goes in a forward direction towards the products B, that only gives us 1 product molecule. But if it goes in the reverse direction, that gives us 2 product molecules. So this reaction is going to want to go to this side, to the right, towards B, the products. It's going to want to have more products, because that is going to lower the pressure. So what will happen here is that the amount of products will increase and the amount of reactants will decrease, so that we have more of B, which is less product molecules. Less molecules need less space, therefore less pressure. Now, we could also do this reaction here and decrease the pressure, and the opposite would happen. I'm not going to go through that example. I think you should be able to work it out based on what we've done. Have a go at it. If you're not sure, talk to me if you can't work it out. But we will look at this molecule here, where we have A, which is just 1 reactant going to 2 products, but this time we'll do a decrease in pressure rather than an increase in pressure. So let's decrease the pressure. So if we decrease the pressure, it's effectively like dropping the concentration, and the reaction is going to want to change to try and increase the pressure. And in this case, increasing the pressure means more products, because we get 2 product molecules. 2 product molecules need more space, therefore create more pressure. So this is actually going to favour the formation of products B. So B is going to go increase, so we're going to see B shoot up here like this. And then obviously, if we are making more B, we're going to have less A. So the concentration of A is going to come down like such. So A going to 2B, if we decrease the pressure, equilibrium shifts to the direction that increases pressure. That's this side here, the products. So it produces more gas molecules. So that's it counteracting the change. It's trying to increase the pressure after we decrease the pressure. Okay, that's the effect of concentration and pressure changes and Le Chatelier's principle. In the next slide, we will look at temperature. So let's look at temperature. If we have a reaction, some reactants going to some products, and that reaction is exothermic, so we know this is exothermic. This is this is looking at this reaction here, this description, because it's got a negative enthalpy change. So negative means it's releasing energy. So this would be so many kilojoules per mole. That'd be a negative enthalpy indicating the energy is being released. Now, if a forward reaction is exothermic in this case, that means that the reverse reaction, so products going to reactants, would be endothermic. So this way would be exothermic, negative enthalpy change, release energy. This way would be endothermic, positive enthalpy change, absorb energy. So what happens if we have an exothermic reaction? The temperature is increased. The reaction tries to counteract the change and lower the temperature. So how's it going to do that? Well, if this reaction goes forward, it releases energy, it gets hotter. So it's going to go backwards. So we're going to get less products, more reactants. So if we try to do that, our products, in this case, are going to decrease, and our reactants are going to increase, because, if you like, the reaction's going to want to go that way to make more reactants, because that's going to cool down the temperature, and we've tried to increase the temperature. Le Chatelier say counteracts the change. So saying that all in text, if the temperature is increased, the reaction tries to counteract the change, equilibrium shifts to the left, favouring formation of reactants, or the reverse reaction. Reverse reaction is endothermic, therefore it lowers the temperature. This can be quite a problem in industry, and we'll talk about this a lot in the next topic, because often you want to increase the temperature to increase the rate, but if you increase the temperature to increase the rate, you might lower the yield, because you're going to get the reverse reaction more favoured. If we had an exothermic reaction and the temperature was lowered, I haven't drawn this and I'm not going to draw it, but we're going to see the opposite. The reaction tries to counteract the change, i.e. tries to increase the temperature. To increase the temperature, we want the reaction to go this way. More products to form, releasing more heat. So we get, equilibrium shifts to the right, or shifts towards favour products. Forward reaction is exothermic, as I just said, so it increases the temperature. Now we will look at an endothermic reaction. So if we've got some reactants going to products, endothermic, positive enthalpy change. If we increase the temperature, the reaction tries to counteract the change and lower the temperature. That means, in this case, the equilibrium shifts to the right. It shifts towards the products because the forward reaction will absorb energy and lower the temperature. So, if the equilibrium shifts to the right to favour products, we get an increase in the amount of products. So the products will go up like that. And if the products go up like that, that means that we're going to use up the reactants. So we will get less reactants forming like such. And obviously in the opposite case, if we have an endothermic reaction like this one, the temperature is lowered, the reaction tries to counteract the change, increase the temperature. So we're going to want the reverse reaction, because this is going to be the endothermic one that releases heat, gets hotter, equilibrium shifts to the left in favour of the reactants. Reverse reaction, 3 different ways of saying the same thing. The reverse reaction is exothermic, so that will increase the temperature. So there we have it. The effect of, we have Le Chatelier's principle and the effect of changing concentration, pressure and temperature on the equilibrium concentrations. Thank you.